Well, hello, 5th grade. Happy Odin's Day. L106, complex figures. So basically, complex figures are figures that are made up of other shapes. And so please draw this up. Our dimensions are in feet. So it's not necessarily a scale. It's not the best picture I've ever drawn, but do your best. So I've got 10 on the top, 12 on the left, 13 on the bottom, and 7 on the portion of the right. So we're going to deal with area today pretty heavily. And in order to find the area of complex figures, we have two kind of paths that we can go down. And sometimes the path is clear for us. Sometimes it's just a choice we're going to make. Here, we're going to work on a particular thing called composite, and we'll write that down later. But the way that a composite area would work is I would take this complex figure and I'd break it up into two figures. See that dotted line I just created there? Boop, 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 boop. What I've done is I've taken this complex figure and broken it up into two rectangles. One of those rectangles I'll just label as A, and the other I'll label as B. So if I was to determine area of this whole shape, then I would say, okay, A is equal to, now if we think about shape A is a rectangle, so that would be an LW. I would then add that to my shape B, which, guess what, is also a rectangle, so I'll just say LW. Then I'd go ahead and plug in what I can. So A is this shape here. So I want to think about the dimensions because there's like 4 different dimensions given to me. It would make sense that that yellowed shape, the shape A, it's using the dimensions of this 10 feet and this 12 feet. And so I'll plug that in. A is equal to, I'll call the length 12 feet times, remember we always substitute using parentheses, 10 feet. Now, going to work on shape B is a little bit more challenging because I'm thinking about this, and clearly the 7's a part of it, but I would need to know what that is. Now, be very careful. Please don't think that that little portion is the 13, because it's not. So how can I figure out what that little portion is? Well, you got to do a little bit of thinking here. So if you think about this 10 on top here and this 13, so the 10 is that portion. And if I took that portion, I added it to that portion, then that would ultimately be 13. So how can I figure that out? Well, it would make sense for me to say 13 feet minus 10 feet is 3 feet. And that's what I'm going to use. So I'll say for my shape B, 7 feet, we'll call the length, and we'll call the width 3 feet, using parentheses. Then I go ahead and do the math. So A equals 12 feet times 10 feet is 120 feet squared. Plus 7 feet times 3 feet is 21 feet squared. Just about done here, and I'll add that up. I'll say A equals 141 feet squared. And I get to box that up, yeah? So as I said before, and I want you to write this down, this is called composite. Like, I don't know if your teachers ever refer to your essays as a composition, like you must write, or they'll say, oh, compose an essay, or like a composer. They create compositions. And what that is like a composer will take notes and chords and they'll put it all together. They'll take little pieces and put it together to create a whole. That's called composite. We're going to try the other avenue we could go. So this avenue is called area as difference. And this word is important and hopefully should make you think about one operation only. Go ahead and draw up this shape and label it as so. So I have kind of like a rectangle, another rectangle. We could go the composite route, but we're going to do this a little bit different. So hopefully you've drawn it and you've labeled it up 14 meters, 10 meters, 20 meters, 5 meters. And the way area as difference works is I'm going to, instead of breaking this up into little shapes, I'm going to think about the shape as a whole. Like think about this and this extending out all the way. So like that yellow whole box thing. I want to think about that whole. And the dimensions I'd use for that would be my 20 meters and my 10 meters to describe the whole, almost as if I've made something that's not really there. Then ultimately, I'm going to think about this part that's not really a part of the shape, of the original shape. It's part of the whole that I made up, but it's not really there. And so what I do is, if I was going to call the whole my A, so I'd say A is equal to, that's going to be an LW, right? Clearly an LW, that is a rectangle, that 10 by 20. Then area's difference is I'm going to, yep, you guessed it, I'm going to subtract off this portion here, that my B. And that, it might look like a square, but it technically isn't a square. So we'll call that LW as well. All right, let's get to work. So A equals, we said we're going to use our 10 meters and our 20 meters to describe the whole. So 10 meters, 20 meters times 10 meters. Then we're going to subtract off this portion. Now, before we do that, we got to figure out, well, what is this portion? So just like before, so if I know that that is that, and there's my 5 meters, so wouldn't I have my 10 meters and my 5 meters, so wouldn't that portion have to be 5 meters? And yeah, it sure would. No, still, it ain't no square. So I know that one of my lengths is 5 meters. Then I want to think about this portion. What number should I look at? Well, I should look at this 20 meters and this 14 meters. And if I look at it and I conclude it, I go, well, wouldn't that have to be 6 meters? Hence why it's not a square. So then I'd say, okay, my length is 6 meters. My width is 5 meters. Then I'm just going to do some math. A equals 20 meters times 10 meters is 200 meters squared. Then 6 meters times 5 meters is 30 meters squared. Then I get to just say 200 meters squared minus 30 meters squared is clearly 170 meters squared, and I box it up. And that, my friends, is called area's difference. I don't always use it, but sometimes like shapes are really set up for it, kind of like this. Now we're going to do 2 more, one composite, one difference, and then we got to explore some angles. So let's dive in. Draw this up. So this one's kind of a strange, like a boot-looking shape, or maybe it looks like some sort of state. Like, I don't know all my state. Is that Wyoming? Who knows? Okay, go ahead and label it. Let's do composite here, okay? So we're going to do it in a composite fashion, which means we're going to do a nice break right here. And you see what I did there is I broke it up into a rectangle, shape A, and a triangle, shape B. So I set this up. I say, okay, A is equal to, now A, little a, is clearly a rectangle. So that's LW. Now remember, this is composite, so I'm going to add on to shape B. Shape B is this thing, which we know is a triangle, and we have a different formula for area of a triangle. Hopefully you know it is BH over 2. Then we get to do our plugins here. So let's focus on shape A. That's going to use these 2 dimensions, 10 meters, 7 millimeters. Be careful there. Sometimes people just choose random dimensions. No, they're there. So 10 millimeters times 7 millimeters. Okay. Now my B, that's the base of the triangle. So I got to do some figuring there. So this portion, well, wouldn't I have to use this? I also got to figure out the height as well. So base and height. All right, so that portion, wouldn't I have to think about the 16 and the 7? Yep, you would. And I'd have to conclude that this must be 9 millimeters. So I'm going to go ahead and write that down. How about the height? Okay, well, what am I thinking about? This portion. So I have to think about the 10 and the 4. Oh, okay. Well, then that's 6 millimeters, isn't it? So, and don't forget to divide by 2. And let's go ahead and do our work. So A equals 10 millimeters times 7 millimeters, which is 70 millimeters squared. And then, I got some canceling here. Let's do it now. So 1, and that'll become 3. 9 millimeters times 3 millimeters is 27 millimeters squared. And I just got to add. And 70 millimeters squared plus 27 millimeters squared is, 97 millimeters squared. That's composite. Hey, let's do another one, area's difference. So here, go ahead and draw this up. It almost looks like a portion was cut from it, like snipped off with some scissors. Go ahead and draw and label it up. 6 centimeters, 10 centimeters, 10 centimeters, 3 centimeters. Remember, we're going to do area's difference. And because we're doing it that way, we want to see this whole shape first. Now, if you think about the dimensions of that whole shape, wouldn't it be 10 centimeters and 10 centimeters? Sure would, which would make that a what? Yep, our superhero shape, the square. So for shape A, the whole, we're not going to use LW because it's a square. We're supposed to use S squared. Remember, area's difference, I'm going to subtract off this portion. And what is that portion? Well, just like we saw before, it is a triangle, right? That's a triangle. But I need to know some dimensions. So I need to know this, which would be my base. So I'd have to think about that 6 centimeters and that 10 centimeters and go, well, it would have to be 4 centimeters. I'm also going to need to know this, my height. So what am I going to think about? Yep, you guessed it, the 3 and the 10. Therefore, my height must be 7 centimeters. We'll call that shape B. So I'll say the base is 4 centimeters. BH over 2. I'm sorry. We'll get to that in a moment. So let's plug in. So we got S squared. That's our 10 centimeters squared. So we'll say 10 centimeters raised to the second power minus, and then my base is 4 centimeters. My height is 7 centimeters. Don't forget, over 2. Ooh, let's cancel right now. Boop, boop, that's a 2. Okay. A equals 10 centimeters squared is 100 centimeters squared. And then, so was that 2 centimeters times 7 centimeters, 14 centimeters squared. And last bit, A equals 86 centimeters squared. All right, uno mas. Now look at this shape. Go ahead and draw it up. This looks like I have a kind of a parallelogram smashed up against a triangle. Everything's in yards. And so 5, 3, 4, and then they give me 2 for the bottom there. That first part is 3, and the second part is 3. Now, clearly, if they asked for perimeter, let's just say they did. They actually did, but we're not going to bother with it. What would I do? Well, clearly, kids, you would think about this and this. You would be at 6, 10, 13, 18 yards. But we're not going to do that. What about area? Well, just like before, this looks really set up for a composite. So I could call this shape A. I have a parallelogram. I would use A equals BH, so like 15 yards squared. And then I have this, which is a triangle. So I'd use BH divided by 2. So 4, 3 is 12 divided by 2, 6 yards. And then I'd add the 2, so 21 yards. We're not doing that, though. I want to focus in on this other information. This guy, sorry, you don't need to do any of that. I want to focus, they want to know what the measure of angle X is. And they tell us that that guy's 37 degrees. So we got to do a little bit of work. What is the measure of angle X? Well, let's focus on the triangle portion. We know that this is a 90-degree angle. This is 37 degrees. So can I say, okay, and then let's call this Y, that angle. 37 degrees plus 90 degrees plus Y would have to be, and you should know, 180 degrees. Let's add, so 90 plus 37 is 127 degrees plus Y equals 180. Then I would subtract 127, and I get Y is equal to 53 degrees. Now, don't box it up, because what they want to know is, what's the measure of angle X? But look at X and Y. X and Y are what we call supplementary. So I could take angle X, add it to my 53 degrees. Notice how those form a straight angle, because they're supplementary. I would say X plus 53 is equal to, yep, you guessed it, 180 degrees. Then I'd subtract 53 from the 180 and end up at 127, and I could box that up. Yeah, kind of a cool lesson. I like this stuff. As I promised, we're going to have a couple double lessons moving forward. So you should expect double lessons on both Thor's Day and Freya's Day. I hope you're doing well. We do have the Real Deal Holyfield homework, HW106. Take good care. Bye.